Hello everyone, welcome to another IGCSE Mathematics tutorial. Today we'll be going over the first topic of the first chapter, the types of number. First, we have some definitions to go over. Make sure to keep these definitions in mind as they'll be useful both in this chapter and in other chapters going forward. First, natural numbers. A natural number is any positive whole number. That does include zeros and negatives. As long as it doesn't have a decimal, it's a natural number. Integers, on the other hand, include both zeros and negatives. Prime numbers. A prime number is any number that is only divisible by itself and by 1. So, 2 is only divisible by 2 and 1, therefore it's a prime number. Same with 3, 5, 7, and 11. It is very important to note that 1 is not a prime number. Square numbers. Square numbers are the result of multiplying a number by itself. So 2 squared would be 2 multiplied by 2, which would give you 4. 3 squared would give you 9, and so on. Cube numbers are the result of multiplying a number by itself 3 times. So 3 multiplied by 3 multiplied by 3 would give you 27, that is 3 cubed. 2 cubed would give you 2 multiplied by 2 multiplied by 2, which would give you 8. It is essential for you to know these tables by heart from 1 all the way up to 15. Factors. A factor of a number is a number that when multiplied by a different number would result in that original number. So for example, we'll take 12. The factors of 12 are 1, which would give you 12 when multiplied by 12. That means 12 is also a factor. 2 and 6 are also another pair of factors. 3 and 4 are another pair of factors. A multiple of a number is any number you would get when multiplying the original number by another number. So for example, the multiples of 2 would be 2, because you get it when you multiply 2 by 1, 4, 2 by 2, 6, 2 by 3, and so on. A reciprocal of a number is the number to the power of negative 1, or 1 divided by that number. So the reciprocal of 2 would be 1 over 2, or 1/2. The reciprocal of 3 would be 1 over 3, or 1/3. The highest common factor. The highest common factor of two numbers is the highest number that can be divided exactly into each of 2 or more numbers, with no remainder. Sometimes you will be asked to find the highest common factor of more than a pair of numbers. For example, the highest common factor of 1375 is 15. You can evaluate the highest common factor of a pair of numbers with division. You start by dividing each number with the smallest prime number that can divide them both. In this case, 3. So you'd get 30 divided by 3, which would give you 10. 75 by 3 would give you 25. You write down these quotients, and you repeat the process until you are left with only prime numbers. So we divide 10 and 25 both by 5, you get 2 and 5, which are both prime numbers. They can't be divided any further. You multiply these prime factors you found to get the highest common factor. So 3 multiplied by 5 would give you 15. The lowest common multiple. The lowest common multiple of two numbers is the smallest number that is divisible by both of these numbers. For example, the lowest common multiple of 60 and 90 is 180. To evaluate the lowest common multiple of a pair of numbers, you have two methods. First, the listing method. You can just list down the multiples of each number until you reach a common multiple. Or there is the mathematical method as shown. You start by prime factorization of the numbers. You divide each number by its prime factors, so 60 would be 2 multiplied by 2 multiplied by 3 multiplied by 5, and 90 would be 2 multiplied by 3 multiplied by 3 multiplied by 5. You write down each prime factor in its exponent form as shown, so 2 multiplied by 2 would be 2 squared, and then we have 3 to the power of 1, 5 to the power of 1. We do the same for 90, and then we find the product of the factors with the highest power. So we'd go into each list of prime factors. We have the 2 squared, we compare that to the 2 exponents on the other equation. So we have 2 squared against 2 to the power of 1. We take the 2 squared, we do the same with the 3, so we get 3 squared, and the 5 is the same, so we just take 5 to the power of 1. We'd get 2 squared multiplied by 3 squared multiplied by 5, so 4 times 9 times 5, which would give us 180. We also have some definitions for fractions. These are the different types of fractions. A proper fraction is a fraction whose numerator is less than its denominator. So 1/2, 2/3, 3/4, and so on. An improper fraction is a fraction whose numerator is more than its denominator. So 3/2, or 4/3, or 5/4, or so on. Improper fractions can also be written as mixed numbers, which are numbers consisting of an integer and a proper fraction. So 3/2 can be written as 1 and 1/2. 4/3 can be written down as 1 and 1/3, and so on. A recurring decimal is a fraction with infinitely repeating numbers after the decimal point, and these have their own notation. So 1/3 would be a recurring decimal, as it's 0.333 recurring. You will be asked to convert recurring decimals to fractions and vice versa. To do this, you set your number as a variable, x, and then you multiply both sides of the equation by 10 if it's only one recurring digit. So in the case of 1/3, you'd multiply it by 10. 100 if it's two recurring digits, and so on. In this example, we have 3, so we'd multiply it by 1000. You subtract your first equation from your second equation. So we do 1000x minus x, or 123.123 recurring minus 0.123 recurring, to get 999x equals 123. We then divide the value we got, so 123, by the coefficient of x, so 999. That would be our value. As always, make sure to simplify your fractions if possible. Rational and irrational numbers. A rational number is defined as any number that can be expressed as a fraction, where both the numerator and denominator are integers. It doesn't matter if it's a proper or improper fraction. As long as both of them are integers, it's a rational number. Any number with an infinite number of decimal places is an irrational number, as you are unable to express it as a fraction. Common examples include pi, or 3.1425, so on, and the square root of 2, the square root of 3, and so on. These have an infinite number of decimal places, therefore we cannot write them as fractions. They are irrational numbers. An important exception you might have already thought of is recurring decimals. We know they have an infinite number of decimal places, but we know that some common ones, like 1/3, 1/6, they can also be written as fractions. Yes, these are the exception to the rule. They can be expressed as fractions despite having infinite number of decimal places, and therefore they are rational numbers. An important note: when answering questions, as always, make sure to simplify fractions as much as possible. You will be deducted marks if you do not do this. Thank you for watching. Make sure to like, comment, subscribe, comment your feedback, and check out the channel for more tutorials regarding mathematics and IGCSE.